We now summarize the chapter. Summary. Chemical or physical processes led to evolution or absorption of heat Q, part of which may be converted into work W. These quantities are related through the first law of thermodynamics via delta U equals to Q plus W. Delta U, which is change in internal energy, depends on initial and final states only and is a state function, whereas Q and W depend on the path and are not the state functions. We follow sign conventions of Q and W by giving the positive sign to these quantities when these are added to the system. The magnitude of rise in temperature depends on the heat capacity C of a substance. Therefore, heat absorbed or evolved is Q equals to C delta T. Work can be measured by W equals to minus P external delta V in case of expansion of gases. Under reversible process, we can put P external equals to P for infinitesimal changes in the volume, making dW reversible equals to minus P dV. At constant volume, that is W equals to 0, then delta U equals to QV. Enthalpy change, that is delta H equals to delta U plus delta NGRT, can be found directly from the heat changes at constant pressure, which is delta H equals to QP. Changes of phase such as melting, vaporization and sublimation usually occur at constant temperature and can be characterized by enthalpy changes which are always positive. Enthalpy of formation, combustion and other enthalpy changes can be calculated using Hess law. Delta H naught R equals to summation of bond enthalpies of the reactants minus summation of bond enthalpies of the products. Entropy is the measure of disorder or randomness. For a spontaneous change, total entropy change is positive. Therefore, for an isolated system, delta U equals to 0 and delta S is greater than 0. So, entropy change distinguishes a spontaneous change, while energy change does not. Chemical reactions are generally carried at constant pressure. So, we define another state function Gibbs energy, which is denoted as G, which is related to entropy and enthalpy change of the system by the equation delta G reaction equals to delta H reaction minus T delta S reaction. For a spontaneous change, delta G system is less than 0 and at equilibrium, delta G system equals to 0. Standard Gibbs energy change is related to equilibrium constant by delta G naught R equals to minus RT times natural logarithm of K. Many reactions which are non-spontaneous at low temperature are made spontaneous at high temperature for system having positive entropy of reaction.